This research work was done at Baker RDI in Melbourne, and it's since been confirmed at Adelaide Uni in another study they're doing with the same mix, with a similar kind of population of people with type 2 diabetes.
Well, the pre-meal concept is a very interesting one because it really follows that the recognition, which has been surprisingly recent, that the gut, particularly the stomach and small intestine, is absolutely central to the regulation of blood glucose control.
The idea of using a pre-meal drink or a preload was to try and harness gastrointestinal feedback mechanisms to improve the response in blood glucose to a subsequent meal. So what we know is that when we ingest any kind of macronutrient, there's a release of hormones from the gut, and there are neural responses in response to exposure to nutrients that modify subsequent metabolism. In particular, gastric emptying of a subsequent meal is slowed by those feedback mechanisms, and that will have a benefit in lowering the subsequent blood glucose response to a meal.
The preload can significantly slow gastric emptying and reduce postprandial glycemic excursion, and also the peak response of blood glucose to a meal. When the main meal is consumed, the gut has been prepared. So the stomach emptying of the main meal is delayed, so the absorption of the macronutrient in the main meal is relatively slower.
Gastric emptying was slowed so that the peak was shifted a little later, probably 30 to 45 minutes later. And virtually everybody had some kind of response, either flattening or shifting or both. So the number of non-responders was pretty low. So when you do the statistics, you get p-values of 0.0001, and you could do the experiment 1,000 times and you would still find roughly the same result in each 1,000 experiments.
Well, what the preload is designed to do is to slow gastric emptying of that subsequent meal, first thing. The second thing it ideally will do is stimulate the release of these incretin hormones, GLP-1 and GIP, and then if you're lucky, will also reduce the amount eaten at that subsequent meal. So there are three ways it targets a reduction in blood glucose response.
But what's indisputable is if you flatten the glycemic curve, your HbA1c should be lower, providing you get enough flattening for long enough.
Again, the rationale is the combination is very logical. So you have a fibre component which will slow gastric emptying and slow absorption by that mechanism, and a protein component which will stimulate incretin hormones and stimulate insulin. So theoretically they should do well together. And the data we've got, I'm part of that team, but it's very much generated by Linda Mignoni and Chris Rayner. And it shows that this formulation does slow gastric emptying, and that slowing of gastric emptying leads to a reduction in postprandial glucose, which is substantial.